Hey everyone, Terry here. It's time for us to start looking at diagnostics as it applies to the idea of working with EIGRP named mode operations. Now, what I'm going to do is I'm going to go back to our topology here, but let's originate a new prefix on R1. Let's take a look at what I want to do here. So from R1, I'm going to create a new interface. Interface LO100. IP address 1.1.1, 255.255.255.255. And what we'll do is we'll advertise this. Well, just to make my life easier, all I'm going to do is just copy and paste my previous config here. Router named EIGRP, plug that in. And what I'll do is I'll say network 1.1.1, 0.0.0.0.0. And now we should be advertising this prefix. Now, the way I'm going to verify that is I'm going to hop over to R22 and I'm going to type show IP route 1.1.1.1, and now we are going to see that I'm learning it from R3 and from R2. Now, the idea was to be able to generate a new prefix because I wanted to take a look at some traces that I have running. This particular video is about diagnostics. So I'm going to take myself out of the equation, throw my pin behind my ear, and what we're going to do is I'm going to see if I can't bring up a listing or an output off of R1. So what I'll do is I'll just pick an interface on R1. We'll say fast Ethernet or Ethernet 00, and let's see if we can't see what's going on. Now, what I'll do is I'm going to take the illustration out of the diagram just temporarily here. And what we want to do is take a look at the output on our device. So right now, looking at this, let's see what we have. I'm just trying to make it fit my screen a little bit better. There we go. So what I'm going to look at right now is EIGRP. And specifically, I want to look at updates. Well, we have a lot of hellos here. Let's see if we can't see anything about our updates. Hello, hello. There's an update. Let's see. From here, we're learning an update from 10.1.101.11, which is going to be Cat1. It's being sent to 224.0.0.10, and it's an update. So let's hit this and see exactly what it says. Now, where I want to go is down here under the Cisco EIGRP, because I want to take a look and see exactly what's being advertised. Now, what we see here is that if you could look on the screen, we have this output, and the output is telling me that I have information for the MTR and for the IPv4 address of 1.1.1.1/32. Now, when we look at this MTR, we're not going to talk about MTR. I want to focus just purely on the IPv4 prefix. So let's erase this and let's take a look at the contents of this table. Now, when I look at it, let's see here. What do I see? Well, notice I see the fact that this is an internal route. And by virtue of the fact that it's an internal route, it's being originated on this device, so its next hop is going to be 0.0.0.0. But where I want to focus on right now is this idea of legacy metric. Now, when we look at the legacy metric, what I want us to understand here is this is the information that's being passed on in our infrastructure. And what's happening is I have my scaled delay, I have my scaled bandwidth, I have MTU, I have hop count, reliability, and load. Now, what's happening here is EIGRP is sending information across our links using that 224, using 224.0.0.10 multicast address, and it's sending the updates for our prefixes. Now, the information that is being exchanged is going to be the information associated with how I computed my metrics. That information is then going to be sent to other devices. Those devices are going to take that information. They're going to aggregate their own information on top of it based on their own delay, their own bandwidth calculations for their segments, and make hop-by-hop determinations using the diffusing update algorithm that we have running in our EIGRP topology, irregardless of whether we're running in classical mode or whether we're running in our wide mode. But however, there are some things I want to point out here that are very interesting. Let's bring back our trace, the output of our Wireshark, And what I want to do now is I want to focus on some more information. We looked specifically, actually this is not the information that I want to focus on. This one is. Let's take a look and see what we have here. I want to focus on a hello. Let's look at a hello. Now that's an acknowledgement. I don't want a hello acknowledgement. I want an actual hello message. Here we go. This is one's coming from 10.1.2011, which means it's coming from R1 and it's going to the 224.0.0.10. Now the reason I want to look at this one is let's scroll down, and what I want to pay attention to is this value right here, my parameters value. Well, if you notice, right now we have our K1, we have K2, K3, K4, K5, but now we have a K6 value. Now, as always, we are going to be using bandwidth and delay, and everything else is going to be turned off to include this notion of K6. Now, we are not doing anything special here. In fact, just to illustrate this point, let me bring up another trace from another device. Let's see here, I'll bring up a trace from, say, R2. R2 is not running named mode. It's running normal operational mode EIGRP. EIGRP. Press enter. And now let's take a look at one of these hellos. Now this one's coming from R2. It's destined to 224.10.10. I'm sorry, 224.0.0.10. And let's take a look and see what we have here in this hello. Well, where I want to go is to, again, to parameters. And what we're going to see is in the confines of parameters, if I can hit it, there it is. We're still going to have, let me go ahead and get rid of this. Delete. We still have this K6 value right here. So what we need to understand is regardless of whether we're going to be running classic EIGRP or our named mode EIGRP, what we see here is as a result of this output, which is going to be information that's going to be exchanged by a device that's speaking classical EIGRP, iOS 15 code has been modified such that now we're going to be exchanging information about this metric weight of K6. Now, what is K6? Well, oddly enough, K6 is going to be representative of, depending on whose materials you look at. First of all, what Cisco's going to say is it's going to be for future updates to EIGRP. Now, future updates to EIGRP, that's one thing, but also what you're probably going to be told is that at some point we're going to have a value of our jitter, accumulate, and also something called an energy accumulate. Now, I can't tell you exactly what each of these values are representative of and how they're going to work because Cisco really hasn't standardized on them right now. All I do know is they're going to be referred to as what's called extended attributes. And there could be these two and others. The key point here is if you want to use these two or any others that are going to be configured in our topology, we're going to have to enable K6 such that it's going to be part of our computation. Now, here's the issue. The moment I enable it here on R1, I need to be mindful of the fact that I can have a mismatch, a K value mismatch. Now, let's look at exactly what that entails. So, by virtue of my configuration, I can test this simply enough by going to any device in my topology. Let's look specifically here at R1. And let's see if we can enable this. Well, we'll go to R1. I'm going to go to my routing process, config T, router EIGRP IP expert. Do show run section router. Make sure I've got that right. Actually, I was playing around and I changed it to named. So let's do that. So it'll be named. Now let's go to address family, IPv4, autonomous system 10, and let's look and see what we can do here with regard to advertising and working with this named mode? Well, first of all, can I just enter metric weights here? Metric weights. Now, we know TOS is unsupported. The next one is going to be K1. We'll leave it on, which is on by default. The next one is K2. K3 we'll leave on by default. K4 off. K5 off. And what I'm going to do is I'm going to say I want to turn K6 on. Now, the moment that I turn K6 on, my connections are going to drop. The reason being is exactly what we described earlier. K value mismatch. Well, that's fine. That's fine. Okay, let's just go to one of these other devices like our Cat1 and see if we can't modify it here. So what I'm going to do is I'm going to say show run section router. And what we're going to find here is my router is going to be running classical mode. So now we'll come up and say router EIGRP 10, and I'm going to say metric weights, and I'm going to specify TOS 0, K1 0, K2 0, K3 1, K4, K5, and what I'm going to do is I'm going to turn 6 on, but it's not an option. Let's see, maybe it's just embedded in the syntax. If I hit enter, will it take it? No, it won't take it. So here's the situation. If I want to run those extended attributes associated with EIGRP, irregardless of what they're called, I need to have named mode running on all of my devices. Now here's another thing that I want to point out, and that's going to be the fact that, first of all, let's go back over to R1 and fix that. Let's turn that off. So no metric weights. Take that out. My two links should come back up, BAP, BAP. And they're operational. Our connections, we have new adjacency has been formed. Everything seems to be good to go. Let's double check and make sure we're learning the prefix on R22 before we do any other diagnostics or observations. Show IP route. 1.1.1.1, 255, 255, 255, 255, and there we are. And just to do it, trace route, 1.1.1, we are load sharing. So now everything seems to be working exactly the way that we want it to operate. Now, let's delve a little bit closer with regard to this context of diagnostics. So from R1, grabbed a real pen, that's not going to work. From R1, let's look at my topology table. So show IP, EIGRP, topology, and what I want to do is I want to look at 1.1.1.1/32. Now we can see this in here, and notice it's telling me it's operating in picoseconds. Now that's nothing new. We talked about picoseconds and how picoseconds are part of our computations when we're using wide metric. Now what I want to do is I want to visit something here. I want to say show run section router EIGRP, and let's look and see what we see here. And there's not a lot of information being exposed. Well, what I want to do is I want to uncover that information. I'm going to use show IP or show run all pipe section router EIGRP. And let's see what happens now. Well, now we've got a lot of output. Let's scroll up and walk through it and look and see what's going on here. So first and foremost, what we're going to find is in the context of our named operation, I've got named and named. Wow, I'm messing up left and right. So this is named. So inside of here, what we have is we have an area called our AF, Autonomous Family Interface Default Config. Anything that is configured here is going to be inherited by every interface by default that we have participating in EIGRP named mode. That's going to include things like my hello interval, my hold down time, whether or not I want to support this add path, which we'll talk about later, passive interface, whether or not we're going to support EIGRP split horizon. All of those are going to be embedded under our interface configuration. So you can see here split horizon is going to be on by default in named mode. So also when we look at this, let's scroll down, and what we're going to see is we're also going to have an idea of our topology. Well, we have a base topology, and then we can have some other numeric topologies, because what's going to happen is we're going to have multi-topology IDs, which we are not going to be dealing with because they're going to fall outside the scope of routing and switching version 5. But it is important for us to understand this idea of our base topology, which is going to be the equivalent of our default topology. So the base is going to be our normal operations unless I specify a special MTR configuration, which we're not going to do again because it's not part of the routing and switching version 5 scope. Now notice here we have our variance command, we have our maximum hop counts, we have traffic-shared balance, we have distance configurations. No auto summary is on by default. So no auto summary is enabled by default. So we're not auto summarizing like we used to in our 12.4 codes. No redistribute maximum prefixes. So looking at this, we can see that we have some pretty interesting base configurations. Now it doesn't end there, because right now what I want to do is I want to focus on these values right here. Metric version 64-bit. Guys and gals, that means we are going to be doing wide metrics. So that's the command that enables this converting from microseconds to picoseconds. And it's also going to be how I am going to be able to decide whether or not I want to use my extended attributes. So if I'm going to run extended attributes, we've already demonstrated that unless I'm in named mode, I can't enable K6. Now the point here is the fact that if K6 is enabled on one device and not enabled on the other, which means I can't have that part of my dual computation, then what's going to end up happening is I'm going to see that K value mismatch output. Now also when I start looking at this, note that it gives me all of the metrics. So I've got TOS, K1, K2, K3, 4, 5, and then 6. And things all roll into this and become easier to understand, because what ends up happening is like I've pointed out, is we have the autonomous family interface configuration, we have the autonomous family topology configuration, and then we also have our AF config that we're using that is going to be representative of our actual config, our actual, what would best be described as our baseline configurations. Let me get rid of that. Where we apply our network statements. Now another point that I want to illustrate here is this idea of metric rib scale. Now we're talking about metrics that are being computed based on the fact that we're using 64-bit metrics to communicate information. Let's see what we have inside of our table that's going to allow us to be able to illustrate this. If we don't have anything, then I'll just simply create something. So right now I think show IP route 172.16.20/24 should be in my routing table. If it's not, I'm going to add it. And it's not taking that, so 255.255.255.0. There it is. Now, what I want to look at here is a number of components. Let's see what we've got going on here. Well, right now, notice I have a metric. The type is internal. And everything seems to be normal. And that's the case. Everything is normal. Let's modify this. Now, we've seen that we can have a named EIGRP configured device communicate and operate with no issues to a classically configured EIGRP configuration. Now, what I want to do is I'm going to pick a device out of our infrastructure and I'm going to have it run named. So we're going to have named to named and then named to this idea of our classical EIGRP config. So I'm going to pick Cat1. Now, I want to make my life easier here, so I'm going to say show IP or show run section router. And what I'm going to do is I'm going to say config T, no router EIGRP 10. Now I'm going to create router EIGRP named. I'm going to go ahead and specify address family IPv4 autonomous system 10. And I'm just going to punch my network statements in here. And what we're going to see is we're going to have prefixes, or our links are going to come back up. And now what we're going to see is we're going to have a EIGRP named to EIGRP named configuration between R1 and Cat1. So let's take a look and see what we got going on here. So let's just up arrow and do show IP route. And what we're going to see first of all here is that this is giving me the information about my routes. But let's take a look at the topology table. Show address family, or show EIGRP address family, IPv4. It's going to be for autonomous system 10. And what I want to see here is my topology table, and I want to look at my entry for 172.16.20/24. And let's see what we've got going on here. Now look at this. This is really, really interesting. Let's take a look and see here. Notice we have a feasible distance. Now our feasible distance was computed through the use of our bandwidth in kilobits and our total delay in picoseconds. Now if I wanted to know what this would be in microseconds, all I would have to do is just knock off the first 3 zeros, and what this would end up being would be 6010, and that would be microseconds. So that's simple enough. So recognizing the fact that now we're taking these values and we're using these values to compute our feasible distance, this is how we get this field here. But the problem is that distance, or that value, is going to be 459,407,360. So that's going to be 459,407,036, or 360. That's the feasible distance. Now if I look at my routing table, show if I type show IP route, and I look specifically for 172.16.20/24, what am I going to see here? Well, if I look, and I'll go ahead and erase part of this. If I look at this, notice that my metric is different. My metric says, well, my metric is 3,589,120. So 3,589,120 is my metric, and we all know that that metric is indicative of my feasible distance. Well, that's in normal classic EIGRP. What we have to recognize now is in this idea of wide metrics, these rules change. And here's how the rules change. Let me see if I can find a calculator here. I need to open this up and see if I can't pull. I usually have it open. Nope, I don't. Just bear with me one moment and I will open my calculator. And what I want to do is I want to take these values. So I'm going to take 459,407,360, which is my feasible distance that's listed in my dual computation from my topology table. And what I'm going to do is I'm going to find out how I got to a metric that equates to 3,589,120. And here is how. What I'm going to do is I'm going to divide this value by 128. Now what you're going to see is this value right here equates this value here. So we have 3,589,120 as what is referred to in wide metrics as my rib metric. So let's take a look at that on the equipment. I'll just grab my calculator and throw it off to the side here because I'm sure we'll need it later on again. So let's again look at this in terms of the topology table. So notice I have my feasible distance, which is my, 459,407,360. And I have what is referred to as my rib metric, which is going to be that 3,589,120. And what I did is I took this number and divided it by 128. Well, how did I know to do that? Well, I know to do that based on the baseline configuration or the default configuration of my device the moment I enable my named mode operations. So I'm going to say show run all section EIGRP, and we're going to actually just use the return button, and we're going to come all the way down until we see this value right here. Our metric rib scale. Now, what we have to pay attention to here is remember, our EIGRP computations are now 64-bit when we're using named operations. That's that idea here of our version for metrics is 64-bit. Now, while the problem here is the fact that the information in our routing table is designed for 32-bit information. So, to prevent situations whereby we could have a computed metric or feasible distance that is so large that it could not be represented in a 32-bit format, we now have this idea of the rib-scale. By default, we're going to take the feasible distance and we're going to divide it by 128. We have the power and the capability of being able to modify that. Let's look at this modification from 2 points of view. So first of all, what I'm going to do is I'm going to grab my config. Actually, we'll just do it this way. I'll grab my configuration, config T, router, EIGRP, named, address family IPv4, autonomous system 10, and I'm going to say metric, and I'm going to be able to enter rib scale. So I'll enter rib scale, and what I can do is I find here I have a value of 1 to 255. So what I'm going to do is I'm going to say 1, do show EIGRP. I'll end it so we can use our context-sensitive help. Show EIGRP, address family, IPv4, topology, and I want to look at 172.16.0.0, and let's say, no, we'll say 20/24. Alrighty, let's take a look at this now. Notice now my feasible distance and my rib values match. So it's going to be 459,407,360. 459,407,360. All because I changed that value for my rib scale to 1. So let's take a look at this and modify the system again. So let's say, let's see, router EIGRP named, address family IPv4 autonomous system 10, and let's do the no form of that to take that out. See if I can't just do to demonstrate that again. Hey, I have to try to remember how to type it longhand. Do show EIGRP address family IPv4 topology for 172.16.20/24. Now what we see is the system has modified it again. Now, the first thing that students think is the fact, well, can I do show run all pipe section router? Can I remove this idea of supporting metric version 64-bit? So the question is straightforward. Can I type no and paste this in and hit enter and change that behavior? Well, let's see what's happening here. Do show run section router EIGRP, and let's see what happens. All. So I'm going to say, what did I do wrong? Do show run all section router EIGRP. Notice it allowed me to enter the command, but it does not actually remove the config. Well, can I change it to something else? Well, let's say metric. And what we want to say here is that we want to modify this idea of our version. So let's say, what if could I do version 32-bit. Hey, it took that command. Let's see what's going on here. Metric version. No context sensitive help at all is coming up to aid me here. And look what ends up happening here. Route configuration changed. Could we have found a hidden command? Do show run section router EIGRP. Let's see what we've got. Do show run all. Notice it took the change. So I'm now not using, I've turned off our idea of wide metrics, or at least we think we have. Let's look and see if the outcome is this exactly what we would anticipate. So end, let's see if we can't take a look at this prefix. Well, notice right now we only have the feasible distance. So it's important to understand that I have the capability of turning off this idea of supporting wide metrics on my device. Notice everything reverted to microseconds. It's now not 6010000000. It is just 6010. So on this device, we're still running our EIGRP virtual router instance, which is going to be named mode, not to be confused with the VRF, a virtual routing forwarding instance. This is going to be the fact that the system knows which particular virtual name we're using. Let's look at that. Config T, router, EIGRP, and what I'm going to set here is a virtual instance. So whatever I come in here and write for my virtual instance is going to be carried over. Now, virtual instance to virtual instance does not matter on the devices. I could, as long as I have my autonomous systems match in my base configuration, everything is going to be operational and fine for my interconnections. So the idea here is that we've outlined the fact that we have this idea of our AF interface default, but guess what? We can also create AF interfaces that are going to be for specific interfaces in our infrastructure. Therefore, we can have the default behavior, and then we can also have a case-by-case interface configuration. We're going to have our address family configuration where we're going to find that we have the capability of doing IPv4, IPv6, and supporting the concepts of multicast. And the last thing I want to do, since this is a diagnostic session, let's see what's going on in our environment with regard to the communication that's taking place between R1 and Cat1. So what I need to do is I need to go to R1, and I want to bring up interface 00, Ethernet 00. Let me scale my drawings over. And let's see what's going on here with regard to EIGRP. Let's see if we can find an update. All right, I don't have any updates. All I have is my hellos. Double check it, double check it. Now, all I see is hellos. Let's take a look at one of these hellos. This one's coming from R1 going to the multicast 224.0.0.10. Notice it tells me my address system, my autonomous system. It's going to give me the information about my parameters. But the question is, what about my metrics? Well, metrics are not going to be communicated inside the confines of our hellos. The hellos are merely the information that's going to be exchanged to bring up our neighbor relationships, ensure we have matching configuration. Our K values are our metric weights, and our autonomous system. If those match, we can bring up our connection. Later on, we're going to find out in things like OSPF, we need to make certain that our timers match, but not in the confines of EIGRP. Now, when we look at this, I need to create an update. And what I'm going to do is I'm going to see if I can't force an update. So the best and easiest way for me to force an update is going to be to clear up my process. So what I'll do is I'll bring back my device. On R1, I'm going to say clear IP EIGRP 10 neighbors and hit enter. And let's see if this forces an update. Well, let's go back up here, and what I'm going to do is I'm going to hit refresh and see if I have an update now. Well, let's see. We got hellos. Hellos. I'm not seeing any updates yet. Oh, there we go. Oh, that was a query. Here we go. We see the hello. We see a query. We see a hello. We see a reply. And let's see, where was that update? There it is, right there. So this is coming from R1, going out, and let's take a look and see what we see if I scroll down. And here are our interfaces. For instance, internal route, IPv4 1.1.1/32. Let's hit that information and see what we can learn from it. And again, notice my legacy metric information. The legacy metric information is all that's being computed or all that's being communicated between these devices. And dependent upon how the local device is configured, what we can do is we can actually determine how we're going to take this information and compute our metrics. Whether or not it's going to be picoseconds or whether or not it's going to be microseconds. And it's all going to be based on how our individual devices are configured. So we can make this exceedingly complicated or we can make this exceedingly simple. The idea here is to understand that if you want to use K6 as a metric, we have to be in EIGRP named mode. If I need to use wide metrics, what we want to do is find out or know the fact that we need to specify that we're going to need to be in EIGRP named mode. However, if we're ever told that we need to go into EIGRP named mode, but we do not want to use the wide metrics, recognize the fact that we can disable that, not by typing the no form, but typing the fact that we want to use the 32-bit metric. And again, this is all going to be uncoverable and exposable if you look at your show run all configurations, one of the commands that I live by when I'm studying, because it's going to give you the majority of all the default configuration commands in the individual sections. So what I want to do right now is this wraps our diagnostics, which turned into more configuration/diagnostics, but you can see how the two go hand in hand. With that being said, let's entertain some more components with regard to how we would do things like authentication and what type of authentication mechanisms we have available to us in EIGRP named mode. I'll see you guys in that part of the presentation. Bye-bye.